In this video, I'll show you how to design this plastic Antweight combat robot with a vertical style weapon. So in this clip, I'm putting all the components together on a piece of graph paper, and I'm using a pen and a ruler to trace it out. So I'm just plotting it on the graph paper roughly where it goes, and I'll use this piece of paper to reference to later for dimensions. And so now I'm just drawing the wheels. I don't have any specific wheels I'm gonna use on this yet, but it's a good placeholder for now. And now I'm just tracing a line to draw it as the body. It kind of just gives you a sense of scale and how your robot is gonna look. And now I'm tracing the receiver onto the paper and all of my ESCs and everything electronic. And it's good to label these things. So the sketch is complete. Now onto the design. And so I've actually gone in and imported all my components already. And so the next thing we'll do is create a sketch similar to the one we created on graph paper. We're actually going to create the body, like the main body. And I will just start tracing a line around the perimeter, kind of just referencing the paper now and then. And despite this motor being off center, I already know where I want it to be. It'll be roughly around here. And don't be too determined on whatever distances you set these to. We can always change that later. And as you can see, I actually have the switch at the bottom of the screen, and I'll actually use this later. And so now I've created the outer sketch. Now what I want to do is offset what I just created. And so if the lines we just created are the outside of the body, then we inset this so that you can see how it's flush with the front of the motor casing. So I'll set that at -4 just for now. And I'll actually go ahead in a second and move that motor back to where it needs to be, but since just nothing's really perfect yet, so we'll work on that. And so now you can see that the sketch has been created. It's a little bit off center. It's a little bit it's cutting into multiple different places, so I'm actually going to extrude this, but instead of using the profile plane, I'll hit offset, and I'll probably just do this -20 millimeters, -20, and that'll give me enough room to work with. And I'll probably just extrude it up 2 millimeters since you don't need to put all your armor right there. And I'll reopen the sketch that we just created, and I'll just extrude it so that it encloses all the components. At this stage, we kind of want more material. We want to lean on the side of adding more material. And so if you look at it from a side profile, I can just move this so it encloses as much of this as possible. So like 35 millimeters sounds about right. And actually, I'll just go up to 40 millimeters to make it easier for me later on. And like I said, I'll just move this motor back. And now you can actually see that this weapon axle is interfering with the body. And usually, to solve this, we'll actually we'll go ahead and just like replace this axle with something smaller, or just go ahead and cut it off entirely. And usually that just works. And so now we have a basic design similar to the one we created in the beginning. And I'll close this sketch out and I'll go back to the main body so we can create the holes for the motor mounts. In closing the bodies out for a second, I'll actually project some of the motor's features onto the sketch, like this screw hole, this hole, and that hole. And I'll go ahead and open the body back up so we can hit Finish Sketch, and we can extrude. I'll just do distance and I'll drag it out to this side. And so that looks good. I'll just hit OK. And now we have screw holes for our motors, and everything should sit fairly nicely. We definitely have enough room in our robot. And for now, I'll create some. I'll create a new body, or rather a new component, and I'll just name it Wheel. This will be our placeholder wheel while we design around it, and this can change in the future. But all I really want to do here is just create a circle, like roughly whatever number you want to put it to, as long as it's big enough that the wheels go past the bottom of the robot. So 50 millimeters looks good. And I'll just put a hole for the motor. This doesn't have to be perfect. We're not actually going to make it in real life. We're just going to use this to reference later. And if you have your own wheels, that's great, but just temporarily, I'll just use this for now. And I'll extrude it out just like 15 millimeters. And this wheel looks good. I'm gonna bring it a little bit farther away from the body. And I'll actually go out into all components so that I can mirror the wheel we just created across the this plane right here. So now we have a more complete looking robot. It's not done yet, but it's definitely closer. And the next thing we want to do is create a side profile of the robot. So we'll go back into main body, and now that we have the dimensions of the wheels and all that, we can actually create a new sketch from the side. And using just the circle tool, I'll just add that circle right there to transfer it onto our sketch. And I'll actually go ahead and project the motor casing right here. And this we can actually just use to reference how big our weapon diameter will be. So it's looking like 80 millimeters. And that for me seems like a little bit too big of a weapon diameter, since the larger weapon diameter you have, the more leverage that's being put onto the motor and more forces in general. So I'll actually just escape out of the sketch and edit that now. Okay, so now I've actually gone back and moved that motor down. So now you can see if we drag a circle to the bottom of the robot, it'll line up at 60 millimeters, and that's actually perfect. Usually I like to stick around 60 to 70 millimeters for the weapon diameter of the robot. And now I will take, for just temporarily, I'll fix this circle, and I'm going to take a line and drag it across these two wheels. And I'll use the tangent constraint to tangent it. Okay, so that looks good. Where the weapon is, we just want to create these kind of standoffs that allow the robot to work inverted. So that looks good. I'll just trim some of this up, make it look cleaner. Now after I've done that, I'm actually going to drag a line from the center of this circle to the bottom left corner of the robot. And what this will do is it'll actually give us basically a better angle of attack underneath our opponent, so we'll be able to get more bite onto our opponent. And just to make sure it transfers, I'll just project this. And the next thing I'll do is I'll just create a line across, but first I'm going to close out these bodies. And looking at this, I can see that we have roughly about like 25 millimeters plus a little extra that we need to come up from the base. So 25 millimeters plus the 2 millimeter thickness of the base plate. So that'll be 27 millimeters. Just drag a line randomly across. I'll set this distance right here. And we want this to be at least 27. I'm gonna make it 28 just to give myself a little bit more wiggle room, or yeah, 28 works. And so that is looking good. And I believe our sketch is mostly complete. I'll just open this back up so we can project this last feature right here. And it looks good. And so I'll just use the extrude tool and I'll cut out all this material that we don't actually need. And this is great. I'll just go across and I'll actually use the symmetric tool so it all looks good. And you'll notice these are the, right here, they're kind of these unwanted areas. I think I'll create a sketch from this face. And I'll just create 2 rectangles that go across here. This is a little bit crude of a method, but it works well to get rid of these imperfections. And it'll just extrude it, and it'll get rid of all of our everything unwanted. And you can see the angle of attack on this robot is definitely better, but there are these gaps here. And so what we want to actually do is create another sketch from the top down. And this one's super simple. Basically, we just want to add a lot more material in the front of the robot since it will be taking more impacts. And so to do that, I'll just drag a line across, and I'll make sure to project all of the features so that this will be a closed face. And that looks great. Now if I select those, and I go to the bottom area of the robot, that should work out. The last thing are just these little defects that we can easily delete. And so that's looking a lot better. I'll still take a fillet tool. I'll just go across and make this a little bit stronger, a little bit more appealing. And now, this is looking pretty good. And the next thing we can actually go ahead and do is create screw holes for the motor mount. And so I'll just go ahead and do that now. And if we close out this body, we can project these screw holes. And one thing I'm actually doing is I'm actually projecting the outside chamfer instead of the actual hole, because it gives us a little bit of room in between the screw thread and the screw thread and the 3D printed part. There's a little bit more room to work with. And first, you'll notice I actually created another circle right in the center, and you'll see why in a second. So this will just go to the edge, and that looks great. And so going back to what I was talking about a second ago, I'll open back up that sketch and I'll just extrude it back 2 millimeters. And the reason why is a lot of these motors usually have some sort of hardware penetrating out of the back of the motor. So like you'll see on this, there's this little nub in the back, and that always gets in the way. It's very annoying to design around. So like it's not annoying, it's just annoying when you forget. So I like to do that before I've done anything else pretty much. And so that is actually looking pretty solid. Now another thing I want to do is create a sketch from the top down right here, and all this is doing is creating a slot for our, you can see right here our weapon cables to go, and 4 millimeters is fine. And we'll just extrude this down however like thick the cables are, so that looks like 8 millimeters should be plenty. On a lot of these things, you kind of want to go a little bit over the dimensions just to make sure there's enough room so nothing is cramped or tangled. And so after all of this, pretty much the last two things we need to do is 1, design the weapon, and 2, design the top plate. I'll start by designing the top plate, but actually right before that, I'll just go ahead and on this face, I'm not actually creating a sketch, but instead I'm creating just a circle to look at, so we can see, yes, there is enough room for the weapon to spin around, so that is good. And now we can go ahead and create a new component, and use everything as a body, and I'll just name this top plate. And that's good. And I'll create a sketch on this top face right here where the walls end, and I'll just project enough of these features so we have an idea of what it's going to look like. And I'll just create lines connecting it. Does not have to be perfect. And now we can extrude this up, and it's usually a good idea to extrude this up the same width as our base plate, so I remember extruding that up 2 millimeters, so I'll do that again here. I've created 2 holes so that we can easily access the screws to disassemble and assemble the robot motor. And now after creating the top plate, the next thing I'll do is need to create the screw holes. And I need to create the screw holes both in the top plate and the main body. And so first I'll actually do it in the top plate, and then I'll transfer them over to the main body. And on the top plate sketch, I'll just project I'll project some of these features with the walls so we can easily sketch around them. And now, using some of this projected geometry we've just added in, we can create some screw holes. And so these screw holes, actually the way I'm designing them, they can actually go on the inner wall line, and you'll see here in a second. And it won't make sense at first. I'll just give it around 3 millimeters. And I'll just create 3 millimeter holes wherever it's needed. It's good to have extra holes in your top plate, even if you can't have weight for enough screws. It's good if screws get stripped out in combat. I'll just turn them into construction lines so they don't interfere with our circles. And so we have half of these circles, and then I will just create a center line sketch, and that looks good to me. And then I'll just take those circles, I'll select them, and then I will mirror them across this line I made. Then I'll hit finish sketch, and I'll just actually extrude all of these circles down into the main body, and this will save a little bit of time. And so I've actually gone ahead and mirrored those holes, and now I'll just hit finish sketch, and I'll select all the holes I just made so that we can extrude them. And so now I'm extruding them down, and I'll extrude them all the way down to the base plate so you can see there. I can click on it, and they're all the correct length, and it's actually cutting into both the main body and the top plate, so that's useful in this case. And now I'll actually go to main body, and I'll edit this. The last thing we need to do here is add material around those holes, so it'll actually be a closed hole. And so I'll just go around and create some finished screw holes. And so I've actually just gone ahead and done that. And I'm sure there is a more efficient way to do this, but this is how it's worked for me, and it's worked fairly reliably. And so I have my screw holes, and I have my top plate, and the last thing I want to do is actually create the weapon. And the weapon geometry, it matters quite a bit. There's several things to account for, and I'll just make a basic weapon design in this tutorial, but in some tutorial down the road I'll make a in-depth design on all the little details that go into making an effective weapon design for a kinetic spinner. And so I'll show you a basic symmetric weapon design. And so I'll create a new component. And I'll offset this plane right here from the bottom origin plane. And using that, I'll just look at it from a right side view, and I'll bring it up to the center axle. And basically now I have an exact cut through the motor with this plane, and I can start my sketch. And I can just follow the half of this motor around the perimeter. And I'm just going through and roughly clicking on the dimensions I want to set it to. And for this robot, since I'm trying to keep this as simple a design as possible, it'll be a design where the motor is supported on the side it's mounted and not the other side. So this is one that would be more susceptible to damage, but it's very easy to design, and I'll show in depth on how to design an effective motor axle bracket in the next video, so you can actually support the other side, or in an upcoming video. And I'll just set this to a random distance for now so I can finish the body. And I'll create a line that marks the center of this motor. And then I'll set this dimension right here, and I want this to be the diameter of our weapon, and that would be 60, but I'll make it 58 just to give us some wiggle room. And that looks great. And I'll actually revolve this around the center line we created. And so we have a circle for a weapon, but it's not actually, it won't actually cut into its opponents. So I'll go in here from a side profile, and I'll just create a sketch so we have a basic tooth design. And one thing you want to pay attention to, since I know the outside diameter of my weapon motor is like 28 millimeters, I want to give myself a good 5 or 6 millimeters further. And basically, I just want to wrap around as much material as possible to make this as strong as possible so plastic doesn't shatter when it hits other bots. And since this is symmetric, I can just design one half of the weapon, and I can revolve the other half. And this is just, it's going to be very simple. It's kind of like this kind of tooth design. And I will create a circular pattern, and I'll just select just these two faces, and I'll select the center point, and I'll just make this 2. I'll finish the sketch, and I'll just remove any material that we're not actually needing. And so if I cut that through, you can see now it's actually a weapon design, and it's symmetric. That pretty much completes our robot. I wouldn't say there's a whole lot else to do except this weapon switch it's specific to my robot, but there are definitely a whole lot of different types of weapon switches, so I would recommend figuring out what weapon switch you want. If you already have one, that's great, and then design that into your robot. I'm just gonna double check that I have enough room for everything, and there are a few more components I don't actually have in this video right now, but it definitely does look like there's plenty of room to spare, and everything should fit nicely. And so that's the basic combat robot design for a vertical Antweight in the plastic class. And so that'll do it for today. Thank you. And just one last note about this robot. This is not a complete design. This is a place to get started with. But you'll likely have to make changes and increase the spacing between things and just optimize it for combat. That's about it. Thank you for watching.